Welcome to another episode of AI Ranch, where we discuss how AI is affecting businesses, individuals, researchers around the world. And this is really like a wild west of AI, where every day something new happens. And today I have a huge pleasure of introducing Dr. William Sawyers, who is a senior lecturer, associate head of School of Business, Computing, Social Sciences at the University of Gloucestershire. Did I tell it right? Yeah, thanks. You're a proper English person telling this as it should. So he's also published a lot of papers, research in topics of bio-inspired algorithms in the civil engineering, artificial intelligence, environment, flood risk management, and so he is, I think, one of these experts which we can look up to on regards of AI, and I'm looking forward for this conversation. And we met with Will when I was studying, and he was studying in the very beginning of this road, computer games development in University of South Wales. And in this episode, we don't want to focus that much on computer games, but maybe in the beginning, more on the real world problems and also these new ethical questions that arise. So welcome, Bill.
Hi, it's great to be here.
So from your profile that you mentioned in university, there is mentioning that this interest in artificial intelligence computer programming sparked from seeing the film War Games. Was it true? And how this movie actually affected you?
Yeah, so it's I actually read the book of the film before I saw the film, because the film was a little bit before my time. It was released the year before I was born, but I did later see it, and it's now a firm favorite. It's one of those ones that I kind of go back to on my birthday or whatever. If I'm watching films for the takeaway, War Games will be one of them. Yeah, it kind of, the story, for those who maybe aren't familiar, it centers around just a teenage hacker who's fascinated by computers. And he's kind of hacking around in his hometown in America, and he comes across a military computer. And the idea is that this military computer has been programmed by a genius to learn for itself and come up with military strategies for the United States. And he gets sort of embroiled in that, and there's a whole conspiracy where the original programmer isn't really dead and so on. But for me, it was both the fascination of seeing someone making computers do really interesting things, and also the idea of a computer that could learn for itself, because I couldn't see any reason why that wasn't possible. It just didn't seem to have been done yet. And at the time, I think, certainly when the movie was released, which I think was 83, it was very much like a science fiction thing, although in academic research circles, the idea of AI and machine learning has actually been around since much earlier than that, as I'm sure you're aware. Since about the 1940s, it really started to kick off. And then it's been through several peaks and troughs since then. But for your general public, and for me, certainly as a young person, I hadn't really come across the idea that computers could do that until that film. So I found that really fascinating. I even tried to code up some programs that maybe could learn for themselves on a BBC Micro, which didn't get very far because it wasn't very powerful. But I think, yeah, the film and the book certainly helped to ignite a bit of a fascination with coding and with hacking and with AI that has sort of been with me ever since, probably.
I agree. Like from myself, science fiction, like Isaac Asimov, Arthur C. Clarke, and authors alike, also has been a huge inspiration. And do you see that these science fiction movies and books affect how we are forming technologies, and especially AI nowadays?
Yeah, I think they definitely do. I mean, they're not often a perfect prediction, but quite often, if you look at films from, say, 10, 20, 30 years ago, the kinds of technologies that you see within them presented as science fiction at the time are often either starting to be around or are already around. So, for example, if you look at the original Star Trek, which was in the 1960s, they had tricorders, which were sort of shaped like little guns. And then in the 80s, in the Next Generation, they had the tricorders, which were more like kind of tablets. And now seeing someone messing around with effectively a large tablet with a permanent internet connection, i.e. our phones, is commonplace. And I think, some of that is going to be because the kind of people who design those devices will have been influenced by those kind of visualizations and ideas when they were growing up. Maybe they didn't take it the exact same way as the fiction versions, but certainly there's influence there for sure.
Let's hope that these dystopian fiction would not prevail soon, right? Or you're not as optimistic. What do you think yourself? Will will we see Terminators rising soon? Or
Well,
how?
this is it. I mean, ideally, we want a Star Trek future, or at least I do, rather than a Warhammer 40K or a Terminator future, right? We don't want fascist empires destroying the world or robots rising and crushing everybody. We would prefer to be working with technology to solve problems and do science and figure things out and work in that kind of way. So hopefully that's the way that we go. I think most people are probably more inspired by hopeful stories, even if they still quite enjoy some of the more dystopian stories as well.
Yeah, that's a good point. Like enjoying a good horror movie, right? But then also you mentioned somewhere that you started programming by the age of 7. That's quite early. I myself also remember those days when I started on MS-DOS, QBasic, and so on. Because in the East Europe, these computers arrived much later than I guess in the West. So, do you miss something about those early days? Do you remember them well? Well, who taught you program?
So it was driven a lot by my dad, in fact. So he was never a programmer. He was an accountant at the time, and later he became an academic. But at work, he was very interested in technology and computers, and he introduced computing to several of the companies that he worked within. And as part of that, he also, owned computers at home. We had several BBC Micros, which were quite a common computer, mostly within the UK rather than elsewhere. But they were basically an Acorn 6502 processor, and then sort of, I think it was 8 KB of RAM, or no,
Mm.
sorry, 32 KB of RAM. So it was a bit more powerful than some of the earlier systems, 32, but pretty weak systems. But we had one of those at home, and that's what I was coding on when I was around 7. So that was probably past the heyday of those computers, but that was just what I had available. And then later on, I did actually use QBasic as well and Visual Basic and things like that. I think with those, particularly the 8-bit computers, so I'm quite a fan of 8-bit computers even now. I still have a Beeb at home, and I have an Amstrad, and a Commodore and various other 8-bit machines. And I think with those machines, the attraction for me about them is that they're of such a simple kind of construction that even though you can't know everything in depth, with sort of a few reference manuals, you can have a pretty good grasp of the whole system. And the way that you code just has complete access to that whole system. So it gives you a real direct control over the computer in a way that nowadays you don't really get it, because most of the time you're several layers, probably tens or hundreds of layers up from the actual machine. So I would say that that direct connection is something that probably
Yeah.
I don't miss because I still do it, but it's certainly something that's sort of been lost in moving from one to the other. The trade-offs were probably worth it, but it was nice to have at the time.
So I also miss the 8-bit games. Like I even set up the some of the games for my kids to play in 8-bit format, right? These NES and so on. So like I myself, even though we both studied computer games a little bit. I also built a computer game company at one point. The way how computer games are made today, I feel they're manipulative. They're like uh, based on dopamine loops, and it's kind of not the way games should be. I think. Don't you miss too? Also, those games from those times.
Yeah, I mean, I probably started gaming on a Mega Drive, which you probably remember, and then I gamed a little bit on the Beeb as well, although I mostly did coding on that more than gaming. But I do miss the fact that the games were simpler then. They were also standalone, so there wasn't this. It's quite common nowadays for games to always have to be connected, and it's getting into an entirely different conversation. So I won't stray too far down the route, but I think that's a shame, particularly in some circumstances where maybe over a period of time, games become unplayable. And so, whereas we have
Mm.
this history of games up to a certain point, after that point, there's a danger that we're going to end up with a dearth in that history, and that feels like a shame. So, yeah, I miss those games. I think they were great, and the simplistic nature of them made them better in a funny way.
Mm.
Yeah.
Yes, for sure. It's if you choose something to give a kid, I would prefer definitely something as simple as that rather than something that's optimized to extract as much as money as possible from parents, right? So that's one thing. But then, how did you decide to change your path, like from starting from the computer games, then now into AI research? What was the path and how do you end up where you are now?
So, although I was quite a keen gamer when I was younger, we had, like I said, a Mega Drive, a NES, an N64, and then later a PlayStation, and a PS2 as well. I only really ended up on the games degree with yourself because I did the foundation year at the University of South Wales. And whilst I was on that year, I spoke to one of the lecturers and said, well, which of the computing courses do you think would give me the best sort of deep
Mm,
coding knowledge? And the advice I was given was that actually, even though you might not necessarily expect it, the games development degree gave you a really good knowledge using C++ and so on, actually manipulating pointers, and that it was a more robust course in terms of specifically coding knowledge than some of the others. So that's how I ended up on that. But then my final year project on that games degree, you probably wouldn't recall because we were all embroiled with our own projects at the time.
yeah.
Um, but it was a neural network training project in C
Mm,
sharp, and it was from they gave us like a list of potential projects, and I picked that one out, and I think it ignited some of that spark that had been left by things like war games and other films and series and things as well. And I found that really fascinating. So when I was looking for ways to further my study, which I was keen to do in terms of doing PhD and postgraduate degrees and things like that, I was looking specifically for something that was more AI related than just games related. And that's how I ended up doing my EngD. So I did an EngD rather than a PhD, and that was based around optimization techniques applied to flood drainage networks, but using neural network and machine learning meta models within those optimization techniques. So kind of applying a bunch of different algorithmic approaches and AI machine learning approaches in combination to try and make a particularly intractable computing problem somewhat tractable.
mm,
So that was really fascinating. I think for me, the thing that I find interesting about kind of AI and machine learning and coding more generally is the idea of like emergent behaviors. So where you can have quite a simple set of rules that still wind up producing some very complex and interesting behaviors that don't look like they could come from those rules. And that's really visible in games and in coding AI and in optimization algorithms as well, which is another interest of mine. And there are some great examples of that if people are interested. Things like Conway's Game of Life. There's a whole rabbit hole you
mm.
can delve down with that particular one. Um, so yeah, I find that
Or
area.
there's also relatable example. The what also Ilya Schulicer is usually saying that when they train the first large language models, which is ChatGPT, then they were training just to model the language, how people normally speak. Like they say, the color of the sky is blue, not brown, right? So most likely next word. So and then or token. So and then they discovered that these models can also classify sentiment of text, like they understand this is a negative text or positive text, and this was emerging behavior from the system, which was not designed to do that. So things like that, right?
Yeah, no, completely. And I was probably going to lead on to that at some point. So you've taken me there. Yeah, large language models are another good example of it because realistically, all the model is trying to do is predict what word's going to come next when you sort of cut it down to the most basic and simplify it. But as it turns out, when you have enough parameters as part of a model and you have the right structure and the right training approach, there's all these emergent behaviors. And I don't want to anthropomorphize too much, but it almost feels like behaviors and understanding and things like that that come from just trying to predict the next word. So you have to have a fairly good model of a lot of things that exist in the real world to accurately predict that next word. And that brings out
Mhm.
behaviors that maybe weren't originally planned for.
Okay, but then let's say for the common folk, like some business person, not the AI researcher listening, what kind of research have you done with AI, like in terms of flood risk management, environments? Maybe give some more practical examples. How what is the inputs, outputs, how the like common person could understand it.
So maybe I'll cover my PhD area or my NGD area rather, because that kind of gives a good example of where a lot of my research has sat when it's more applied. So in that case, it was looking at drainage models, specifically within the UK. So we have what's called a combined sewer network, which is quite common across a lot of Europe and the UK because we built our drainage systems fairly early in the process of them. Um, I promise this does relate to AI eventually.
Sewer systems, very good.
Yeah, yeah. And so the idea is that actually what we wanted to do was predict the risk of flooding in terms of cost to infrastructure that was linked with certain sewer systems. And that's made complex because there's different shapes of pipe that can affect how fast water can move around. There's different sort of storage areas for water. You can do things like drain off excess water into river systems, which any UK listeners will be very familiar with at the moment because it's been in the news over here a lot, that companies are doing it too much. So there's all sorts of parameters and things that you can feed into an optimization algorithm and then say, okay, let's run a model for each one of these sets of inputs and let's see what risk it gives us. So you might tweak, for example, the pipe sizes or the storage area sizes and see how that changes the number that it gives you, which is the risk of damage to infrastructure in a cost model.
Mhm.
And that's a perfectly effective way to do it. The problem is that doing it naively like that with the models and specifically with the compute power available at the time, or even probably nowadays, to actually do that exhaustively and get a proper answer would take you longer than the lifetime of the universe to actually run everything and get something. So you clearly can't do that. So what we did was we brought in what are called meta models. So really they're just models of models. So neural networks which were designed to help predict some of these areas within the sort of model that's trying to predict that flood risk cost. And the idea is that by doing that, you get an answer which is less precise than the actual answer that you would like, but it's much quicker to produce. And it therefore, even though it's less precise, is worth more because you can actually bet it within a reasonable period of time and do some action based on it.
Mhm.
And so by doing that and some other tweaks, we managed to get it down to a somewhat reasonable runtime of kind of months or years versus tens to hundreds of years for running that model. So that's
Okay.
where a lot of my research has kind of sat when it's more applied.
Yeah, and in the like a little bit broader perspective, the how close we are of nowadays the AI systems. Some research has been changed over the years, like the way how we built the artificial neural networks 10 years ago. It's kind of different nowadays. Also, the availability of data, quality of data, so on. So regarding my question, so the how close we are of AI being able to solve some of these environmental issues, prevent natural disasters. Are you aware of some institutions using it already in that way? Maybe we are not aware of it. What do you think?
So I think AI can definitely predict natural disasters. I couldn't give you concrete examples off the top of my head, but I'm pretty sure that with a little bit of searching, I'd be able to find them, probably even in some of my more recent publications, wouldn't be surprised. Because predicting whether they're going to happen or not isn't that challenging a problem, because there are usually sort of specific key parameters that humans have already identified with their years of research on these topics. So you can see, for example, if I don't know, the pressure in an underground magma chamber starts to go up, that probably starts to hint that you're about to have a volcanic eruption at some point in the future. And I can't see any reason why AI, as it stands now, wouldn't be able to predict that probably pretty accurately. I think the difficulty is two things with that. One is that you have to be very careful about your predictions, because if you're using a system, which a lot of AI is, that's kind of a black box where you feed in data in and you get an answer out, you don't really know how the answer came from the data, then there's a risk there that if you make an imprecise prediction, say there's going to be a volcanic eruption, you evacuate 3 cities around the volcano, and then there isn't one, well, someone's going to say, hang on a minute, who's going to pay for that massive economic impact that your AI model has just caused? And I think in order to be able to determine things like that, you probably need more explainable AI, or you need lots of backup experts working with an AI system. Or you need to try and make sure that you only ever get the kinds of error that you can deal with. But I think in both kinds, sort of type 1 and type 2 errors, so when you get false positives or the other way around, there's probably still consequences either way.
Yeah, I believe the explainable AI and the frugal AI. So frugal AI means that we don't need as much data to train it, and explainable would mean that, as you said, it's not a black box. We understand why it does things it does. So it's a one way forward to make sure that these systems can be applied for some very serious and multi-dependent processes like environmental issues. So, but in regards of that, like even with language models, you can start asking questions about environmental issues and how to solve them. And the models have been trained on some part of data that have some sources arguing against and for different solutions. So the question is, what kind of ethical issues you already see rising of using, let's say, language models or other techniques to trying to solve issues that humans cannot solve regards the environment?
So I think that there are the ethical issues that I've touched on with regards to imprecise predictions and so on. There's also things around how AI models will actually be able to solve issues. So I think inevitably at some point, at least with technology where it is right now, there's going to be human intervention. If AI is going to solve something or prevent something, there needs to be a human intervention, and at that point, humans are linked in, and a lot of the ethical consideration probably needs to sit at that point where the humans need to be linked in. You raise an interesting thing with large language models, because yes, you can ask them about environmental disasters and predictions, and you may well get an answer that makes sense, but there's also a risk, because the only learning or training or knowledge that an AI large language model has is the data set that's gone into it, and any biases that exist within that data set are going to be replicated in the outputs that come from the large language model. And there are some things you can do in prompting to try and prevent that, but there's always going to be an element of that coming through. And we might not even always be aware of those biases coming through, because they're probably going to mirror our biases, particularly if we're from the culture that a large portion of the data set has come from, for example. So
Yeah,
me being from,
the one example, I think this at least the early versions of GPTs had quite a significant portion of data set coming from the Reddit, and the Reddit audience is mainly one way of thinking of people, right? And then if I remember early days, nowadays that it's more balanced, but early days you would ask GPT about using fossil fuels to advance third world countries, right, where they don't even have running water, so that they would have living conditions improved. And the GPT would answer in the way as Reddit commentators would answer that this is totally unacceptable, that they should live without fossil fuels and so on. And that is in the direction of just taking at face value ethical problem, right?
yeah, completely. And the way that they work, so we touched briefly on it earlier about them sort of being based on the principle of predicting the next thing that's likely to be said. Um, that's based on their data set, right? So if they have a large proportion of something like Reddit, or even another online community of some sort in their training data, then that's going to bias them slightly towards reacting in the same way that a Reddit commenter would, as you say, or I don't know, a TikTok commenter or a Daily Mail commenter or whatever data source it is. And so you don't get it. It doesn't, just because it's a computer doesn't mean that it gives you a completely unbiased and clean, perfect view of everything. In fact, it's quite interesting because in some ways, with a lot of models, unless there is something that you might consider a bias within the data, i.e. some imbalance or something like that, there's nothing really for a machine learning algorithm to work with. There needs to be some imbalance for it to be able to
Yeah,
actually
sure.
learn and predict stuff, doesn't there?
Yeah, you don't want to have just the noise, right? Just so
Exactly.
that you need some kind of this structure, and the structure comes with these biases. But then, if do you see the risk that people trust too much these systems, and like imagine the case that even if they would be able, which they are not able, close, they're basically very far of that, to train large language models on the whole internet, like theoretically nowadays I would think it will take 10 years on the best hardware to do that, but if they could, and then if this large language model or some other AI system would classify humans as parasites on earth instead of caretakers, and we should get rid of humans, like and somebody would just blindly trust this, is that path something that could happen, and how we should deal with this, how we could make these systems work for us, not against us?
Yeah, I mean, there's a few questions in there, I suppose.
Yeah.
So the first one is around trust in large language models in particular, but probably in AI in general as well. Um, I think you can only ever trust an AI system or a large language model, which is just an AI system, as much as you would trust someone who has a perfect knowledge of the training set that it has, and probably not even that much, to be honest, because there's some um, sort of randomness inserted into the algorithm to give it interesting responses and things like that. So in that sense, I think people have to be educated and have to understand how to use the tools and what they're useful for, what you can trust them to do and what you can't. They're very useful for things like, I don't know, helping to draft emails or write text chapters. But ideally, people shouldn't be relying on them completely and just copying and pasting stuff straight from the model into something else without editing it and thinking about what it said and whether there's a better way to put it and so on. And then the second part of the question is perhaps more sort of that doom and gloom Terminator scenario. What happens if we trust an AI model completely? Maybe we have a big one that's in charge of making decisions to help governments or something, and it starts to say things that are negative towards people. Um, that's ultimately linked to something which I'm sure you will have read about called the alignment problem, where we're trying to make sure that what we're asking AIs to do actually aligns with what we want them to do, which isn't always quite as straightforward as it would seem. Um, so, for example, if I ask an AI system to, I don't know, say it's a robot, and I ask it to go across the room and make me a cup of tea, um, it's going to do that fine. It would be fairly easy, even nowadays, to create a robotic system that could do that with enough funding. But there's a difference, right? Because if I asked you to go across the room and make me a cup of tea, and there's a child in the way, you know that there's a subtext there which says, don't just stand on the child in the middle, go around them and get the
Hmm.
cup of tea and then come back. An AI model might not necessarily have that
Sure.
subtext unless at some point it's put in, whether that's by a coder or whether it's part of the prompting or something like that. So there are extra context and information that we perhaps have to give them that aren't straight away obvious to us to make sure that the responses we get are actually aligned with what we would want in reality.
Yeah, nowadays I see that alignment often is used also like an excuse for all sorts of biases, because it's in general also towards some kind of general bias of the system. And but at the same time, I believe that in a bigger picture, we do need some alignment in I think one example might be Isaac Asimov's rules of robotics, and it's kind of strange and funny how a few years ago the everybody told that using computer programming this and the training neural networks as it was, these rules, it's impossible to implement. But nowadays it seems that it might be possible, like just to remind the rules. So there was this science fiction writer in 40s and 50s who was predicting all sorts of science fiction that is like the technology that we take for granted today, plus also things that really appears today and tomorrow. It's really interesting. But then it said that there is these positronic brains. There are these AI systems in the world that work together with human beings, and he especially talked a lot of psychology and how we interact with these intelligent beings in our systems. And the rules were the first one: that robot may not injure human being through the inaction or direct action. Right, the human being is the most important. You cannot harm it. Then the second, robot must obey orders given by human, except if that conflicts the first law. So always do what human says, but never do harm to human. And then the third one, robot must protect its own existence as long as it does not conflict with first and second law, which is the autonomy, that this agent can do things on their own, make decisions as long as it follows the orders and do not do harm. So then my question is, do you see something like that possible in alignment, and or you still think that you're far away from implementing something like that?
I think it's an interesting example to bring up because you're right. A few years ago, it seemed quite ridiculous. I think there are still issues with it, although who knows where AI will go in future. But it seems less ridiculous in some ways now than it did then because we can give computers through large language models and things these human instructions and they can interpret to some extent in some way perhaps with the benefit of their training data to support them. Yeah, I'm familiar with the rules. You missed off a rule. In fact, there's the
Oh yeah.
Zeroth rule as well, which is a robot must not harm humanity or through inaction allow humanity to come to harm, which prefaces the others and came later in the series. Although I'm more
Nice.
of a Foundation fan than robots, but yeah,
Nice.
but yeah, I think there's that question around some of the definitions in the terms is the biggest issue with those rules. So, for example, if we take rule one, where it must not harm human or through inaction allow a human to come to harm, that's great. Except how do you define a human? Because that's something that we as a society and as humanity generally still struggle with. There are some cultures that would define only members of that culture as a human. I'm not going to pick out anyone in specific, but there are these cultures around different places. There's also arguments around at what point after conception does the result of that conception become a human, right? We don't have a concrete term for that across the whole world. We don't really have a concrete decision on whether it's instant, whether it's a specific amount of weeks down the line, how that contrasts and should be balanced against the needs of the mother, who's definitely a human all the way through. And so there's all these different questions around the definitions of specific words, which I think maybe in the future we might create models that had a broad enough understanding. Would never say never, right? But at the moment, they're definitely not there with that
Mhm.
understanding. And it's probably
Yeah,
difficult because, let's go ahead.
no, the logic, decision making, that's one area where the language models, how there's room for improvement. The one thing that we already see in GPT-4o and also in GPT-4 is that they are starting to move from just from the semantic language models to symbolic representations. Like if you look at GPT-4 and you put their Excel sheet and you ask to do some manipulations, it will produce Python code, then execute that. And the Python code itself, it's a symbolic representation of the task. So I believe that these kinds of also ethical and logical parts of structure will at the end be formalized as these symbolic representations rather than just black box language model, right?
Mm. Well, I think there's a question there which hasn't been fully answered yet, which is around whether large language models and similar large models based on a sort of transformer architecture are actually forming some kind of emergent world model internally to allow them to undertake their tasks, which certainly sometimes appears to be the case, but whether that genuinely is hard to say. And that applies to whether they're language based or whether they're linked around taking in images or taking in sound, because realistically, at the end of the day, it's all just data that's being fed in. And so you can feed it in and use the same architecture to make predictions about it. Or whether it's a purely statistical thing with some randomness added, which a lot of researchers might say would be the case. And there is really no emergent model in there. Um, I kind of hope that there is one, because that seems like it's the more interesting
More
to
exciting.
me. Exactly, yeah. And if that is the case, then bringing in more multimodal approaches to it, I think can only improve that sort of nascent internal proto model that maybe.
Except the what the data shows so far, at least from like the big players like the OpenAI, that GPT-4o is less performant on some of the logical tasks rather than GPT-4, which is the unimodal that, and you understand yourself that the way how these architectures are made nowadays, this is definitely not the way how it will be made, let's say in 5-10 years down the road. And right now, actually, this multimodality where you learn from a sight, from sound, it is more like a gimmick rather than actual benefiting the model just to understand world better. Do you agree on
Yeah,
that?
I do, but I think it's an interesting thought process, right? To take it through and go, okay, well, if we're going to have lots of different inputs, then if you make the assumption that there might be some kind of very initial beginnings of some kind of model in there, then those things could be fed into that and improve it. And I also don't think it's necessarily wrong. Granted, the architecture, as you say, will need to change, I think, for this to actually happen and get anywhere if it ever does. Um, but I do think that as you add different information in, it's probably not unlikely that error rates go up before they come
Mm.
down. So that's not really a surprise. I think you can see the same thing to make a comparison, which hopefully won't offend too many people. If you look at the development of children and stuff, as you give them more and more information, it doesn't just in a linear fashion make them more and more correct over time. There's peaks and troughs in the way that they develop and the way that they make connections. Um, and so there's perhaps a comparison there that could be made. I'm not saying they're the same thing at all, because they're very, very different, obviously.
So there's like a huge number of topics we could continue discussing. I already feel that we all need another episode with you. But regarding the other direction that I think you have researched, so this is the healthcare solutions, or any kind of AI related things to healthcare. So do you see already some current technological opportunities that have not been used, or well, in the UK, do you see that regulation climate, like what is allowed and what's not allowed to do with these technologies? Is it too tight? What are the limitations? Where we can go more? Can you talk about your
Yeah.
experience in healthcare?
So yeah, I think there's a lot of ways that AI and machine learning techniques can contribute to healthcare. There's loads of things which are being looked at the moment. So there's stuff around prediction, like diagnosis and prediction of diseases in people and things like that. There's some publications that I've done recently, although it was really more a PhD student of mine who wrote the publication, but I fed into it a bit. But I think there is that balance between, as you say, that the regulatory and access to data is really the key bit of that. I think the regulatory frameworks and the access to data and the machine learning models. And there has to be a balance, because if you just take all the data, for example, and you give it to machine learning researchers, then yes, they could probably advance the ways in which that could be applied and help people. And that's broadly a good thing. But there's the whole privacy implications of that. There's things around whether it's ethical to use that data, whether it's ethical to use the outputs from the models. So, for example, if a model says, let's say, for example, that you go into hospital and there's a machine learning model that says, actually, Evals isn't worth treating because he's probably not going to last much more than a few weeks. Would you want them to just not bother on that basis? There's a lot of thorny ethical issues around it, isn't there? So I think that access to data is a big one, but it's not something that can be simplistically overcome. It's something that needs to be worked at bit by bit between kind of AI researchers, academic institutions, perhaps private companies that have an interest in the field, and the healthcare providers, whether that's private healthcare providers in some countries or public healthcare providers in others, kind of all need to sit together and work together to support each other. And so probably collaborations between healthcare providers and AI machine learning experts to progress these types of things in specific areas where they've decided it's worthwhile and ethical to do so is perhaps the near future way of approaching some of these problems.
But the main source of making it go very slow, it's the main friction points. Are they like in the availability and quality of data, technology, regulations, or maybe which I see also significant friction is the readiness of the market and the public, because they even don't realize what you can do with this. What do you think?
Yeah, I mean, all of those is the answer. There is the readiness of the public to take part in it. Like that example I gave you, it would clearly be fear mongering because we'd never place that kind of decision on an AI model purely. But that's the kind of thing that people will ask and worry about, I suspect. And so there needs to be that trust in technology, but also in the people who are using that technology. I mean, we saw that in the UK during the pandemic. There was a track and trace program in place, which was part of it was an app on people's phones. And quite a few people, to be honest, weren't really interested in taking part in that, despite the societal benefits that people thought would come from it, because there's a bit of a lack of trust, or there was a bit of a lack of trust in the government and the specific bodies that would have access to that data and what it would be used for and so on. And so there was a lot of work done around trying to address those concerns and make it more palatable to those people. So that definitely is a concern. And then equally, as you say, the quality of data, I can only speak for within the UK now, because those I've only worked really with NHS bodies within the UK. The quality of data is quite challenging. I'm assuming it's probably similar elsewhere.
Mhm.
There are central databases and data sources within NHS trusts and hospitals within the UK, but equally there's a lot of what IT practitioners would call shadow IT, where one ward might have a database that they're using to track specific things, and that might be in, I don't know, an old version of Access or an Excel spreadsheet rather than on a SQL server. And then another ward will have something different, and the so on and so on. And so realistically, if you wanted to connect all that data up, that's quite a big task by itself before you can even
Mhm.
really use it for anything. Now, I know there's been a lot of work done on that since I was working directly with people, but I think it's still an ongoing challenge as well to actually make that work and make it usable. And then access to data, because of the reasons we spoke about, privacy
Mhm.
concerns, ethical issues, is another thing. I mean, healthcare data can cover quite a wide range of things. If you're, for example, say I don't know, a takeaway owner and you've got some kind of unpleasant disease, do you really want all your customers to be able to look it up and know that you had that and you work at this takeaway, because it could affect your business? So there's ethical issues that aren't necessarily even linked to privacy, but could be valid, business concerns and things like that. So I think there's work there in terms of making sure it probably comes back to some extent to trust there as well, but from the owners of the data rather than from the general public. But ultimately, those are probably the same people at the end of the day, just being looked at in different views.
Okay, okay, but yeah, I hope you agree that there is this huge potential, and maybe you can share if you have any concrete examples where already the AI technologies, especially these that understand the text and the patient histories, already are giving better diagnosis or better treatment. So, or we are very early there.
So there's definitely a lot of work, including the work that I've done, like I said, with my student, around deep learning being applied to feature extraction for medical images, which can help in diagnosis and things like that. Computer vision, I think, is an area where actually it's one of the first areas where deep learning, which is perhaps falling out of fashion a little bit as a term now, but is still realistically a thing that we do, became popular, isn't it? Around about, I think it was 2011, 2012. The first kind of ImageNet paper was published, which
Mhm.
used deep learning to really
Mhm.
dramatically improve the accuracy of identifying things in images. And it's jumped on massively since then, as you can imagine, with the
Mhm.
improvements in technology and the power of computers and so on. So I think that's an example of an area where the machine learning technology has kind of started to reach a point where it's been around long enough that it's generating
Mhm.
some of that trust and finding applications in places that it perhaps wouldn't have done when it first became available. And therefore, I think other deep learning, machine learning based areas probably have that time lag where the technology needs to be well understood, it needs to be trusted, people need to know what the limitations are as well as what the possibilities are. And then that
Mhm.
will start to allow it to come into its own in some of these areas where actually there's very justifiably a very risk averse approach. But equally, I do completely agree with you that AI technology has the capacity to completely revolutionize healthcare, and
Mhm.
possibly even to democratize it to some extent, to make it
Mhm.
actually available in places where previously it wouldn't have been, for cost reasons or
Mhm.
for expertise reasons or for various things like that. Um, you can
Yeah, I
imagine, for
agree.
example, yeah, yeah, you can imagine in even in areas at the moment where there's lots of areas where issues are going on in the world, shall we say, without delving too far into that. And I can imagine that actually probably there's interesting things being done with the support of large language models that perhaps wouldn't fly in a more normal time, but hopefully are being helpful and helping to support some of the efforts going on there.
Mhm. Yeah, especially this time lag of technology being mature enough to work in highly regulated environments like the healthcare. That's something that is understandable, at the same time a little bit frustrating when you see how fast language models develop, and you know, you kind of feel where it will be about 5-10 years down the road, but it's not going as fast. So I agree on that. But then towards the end, there's another thing related to what you do when you work with students, and especially in this and also healthcare. So there is this meme going around the internet. Maybe you have seen it, with actually Englishman, Mr. Bean, right? who is pretending to be a surgeon, right? And then you wake up on your bed in hospital, and there is Mr. Bean with the scalpel, right, with the knife, and he's ready to cut you out. And it says that below the meme that this is your friend from medical school who did all of the exams using ChatGPT, right? And now he's going to perform a surgery on you. So then you're totally scared. So are you concerned about this and the effect of not only ChatGPT, but there's lots of AI search engines, AI assistant tools to automate like writing exams, writing reports, writing publications, and do you see it already affecting you?
Yeah. I mean, we've had lots of internal meetings here at the University of Gloucestershire, and I'm sure other HE institutions have been doing the same around what to do and how to address this. And we have some kind of policies in place as sort of a starting point that we can perhaps look to build upon as technology advances and as we see how those actually impact. I think longer term, what we're probably going to have to do in education in general is think about how we assess knowledge and understanding in a way that makes sure that it is the knowledge and understanding of the person, but also think about what knowledge and understanding we are assessing and for what purpose. So, for example, um, at the moment, for example, if an essay is written with ChatGPT, it's an issue for various reasons. Obviously, there's the plagiarism issue, there's the fact that it's not their knowledge, and there's the fact that actually probably it's a pretty bad essay because at the moment, the kind of work that these models produce tends to lack a lot of critical analysis and things like that, because at best, it's likely to respond in the way an average person would, even with careful prompting, which isn't necessarily the best way to produce a really good essay, which you want to be better than what an average person would produce. But I think if we want, for example, to democratize education a bit more, make it more open, will it matter in the future if some kind of model has helped to generate the text if the understanding is still there with the student? It's a little bit like arguing whether it's okay for students to use a word processor rather than handwrite in some sense. So that the key is to make sure that the knowledge and understanding is still with the student and hasn't come from somewhere else. But if that somewhere else, something else is used as a tool, that's not necessarily a problem all the time. Um, so it's a tricky thing. I mean, maybe we need to move more towards things like presentations, perhaps exams for specific topics. We've kind of moved away from them a bit, generally speaking. They're still used a lot of the time, but I would say less
But I
rigorously than
think
they were used in the 60s or whatever.
yeah, that's a fascinating thing, especially regarding all sorts of latest technologies. Like one, because of deepfakes, because of the also the AI. It's I know already lots of companies where they have critical decisions you would do these things in person meetings, and also the remote education where you would a few years ago do the whole courses online. Nowadays, we cannot trust any certificates from remote education because you could automate quite a good degree, quite a good grade on these exams, and the essays also something that or reports it's almost like a cryptographical issue because you can generate a report easily, but also with lots of context, lots of facts, numerical values. But then for reviewer, the grader, the teacher, it takes a huge effort to understand what is actually the good part of knowledge inside that report. And for student, it just takes like 1 minute, well, not 1 minute, but let's say 30 minutes to generate this stuff. So in the RTU, the Riga Technical University, at least in my courses, I tend to go back to very basics to being to test actual real exams where you cannot use any additional tools, just to make sure that your base knowledge is up to the level so that AI can multiply it rather than being nothing. Do you agree on that?
Yeah, I mean, I think that the idea should be ultimately that AI is going to be a fantastic tool that a lot of people can use. It should be a force multiplier, but it shouldn't replace the human knowledge that underpins it. For a couple of reasons. One is because we can trust humans more because we empathize with them more, certainly at the moment, at least culturally. Also, at the moment, humans are well ahead of anything machine learning or AI related in terms of being able to come up with innovative solutions and think creatively and all that kind of stuff that AI models realistically can't really do. They can sort of simulate it to some extent, but it's not there in the same way. Um, and then also, I think the need is there to think about what you actually want to get out of your assessment, what you want to know about the student from the assessment, and how you can make sure that that is what you're finding out. Um, so, for example, I mean, I remember on my undergraduate course, and this was many years ago, which is the excuse. I'm sure the university doesn't do it the same way now. You probably remember as well, in our final year having exams where we had to handwrite C++.
Yeah.
Most universities wouldn't do that now because it's not a realistic way to figure out what someone's coding knowledge is. But maybe some people from that time period might have been concerned, going, well, okay, but if you allow them to practice coding in an environment where they have autocomplete and stuff like that, is that not
Yeah.
diluting the experience? So you kind of have to thread that balancing act and figure out what it is that you're trying to teach people, and then assess whether you've successfully taught them that. And some of that's going to change because I think there's going to be a massive culture shift that happens around AI. I think we're on the cusp of it at the moment. We're not actually
Mm,
really moving into it yet.
I
We're just sort
understand.
of on the precipice. And once
Mm.
that happens, the kinds of careers that people can go into may well change. The kind of things we're trying to teach people may well change. And therefore, we might need to assess different things than we did in the past.
Mm. Yeah, like it's been like really in-depth conversation, at least for me. And many topics I want to continue discuss with you. We'll need to set up another call, another discussion with you. So at the end, where could researchers, potential partners, find you? How can they get in contact with you?
So I'm on LinkedIn. You can look me up as Dr. Will Sayers or Dr. William Sayers on LinkedIn at the University of Gloucestershire. I have a university page on the website, so you can look me up there. I'm on Twitter as well, or X now, but I don't use it all that much. So any of those places is fine to try and get in touch. And I'd be really interested in particular to hear from if anyone has some ideas for sort of cross-disciplinary research that they'd be interested in undertaking. I think that's a fascinating area, and it's an area where our school, business computing and social sciences, as you can hear from the kind of title, it's quite a cross-disciplinary school, and it's one of the areas I think we have real potential to offer value and grow. So if anyone has ideas like that, please reach out. Happy to hear from you.
So yeah, I'm really happy to talk with you. That was really exciting. I look forward for another conversation down the road. And thanks for joining.
Yeah, no problem at all, Evalds. All right, nice to speak to you too.
Okay, bye-bye.
Cheers, bye-bye.
Thank you for listening to another episode of AI Ranch. As a gratitude for our work, please subscribe and share this video to your friends. Bye-bye.